Hello, and welcome to my talk, which is Compose Yourself, SwiftUI and its Android counterpart. They said this was a good talk to do at the Google office. Maybe it is. Maybe it means I'm talking to a room full of experts, and it's a terrible idea. But here we go. You can all tell me in the break about all the things I've missed. That's clicking someone else's slides. Okay, I'll just do the laptop. That's fine. So in case you have forgotten what this talk is about, it is about the native mobile development world, which has gone fully state-driven and declarative. Hopefully you all know that. But how does SwiftUI compare to Jetpack Compose? I rebuilt my native iOS app, Get It Right, originally launched on the App Store using SwiftUI in Jetpack Compose for Android, now live on the Google Play Store. So I've tried out Jetpack Compose, so you don't have to. In this talk, we'll explore how both ecosystems handle state management, releases, data, and architecture, highlighting their differences, similarities, and quirks. So this talk will go through a few introductions, then we'll discuss why an iOS developer would care about Jetpack Compose, then the comparison, and then there's a quick summary. So first, allow me to introduce my personal app. So my personal app is called Get It Right, right spelt the written way. And this is my personal app. So apparently, and this is a statistic I got off Reddit, so please don't fact check this. Apparently, 60% of people in the UK are writing a book at any one time. So that's my target audience. It's the gamification of creative writing. So it tallies how many words you've written on the app. It lets you add words. It sends you a daily notification if you really want to be annoyed by the app regularly. It's got a focus mode to help you write in. And then it's got a place to track all of your writing projects. And then obviously I've messed around with Swift charts, so you can see the very beautiful charts. There's some badges you can earn, and there's a couple of games that you can play inside the app with some regular writing prompts as well. So yeah, that's my app, as you can see. And here it is on the Google Play Store. I would say slightly less flashy because it's Android, in my opinion. Hopefully that's a good audience for that one. But yeah, it's got all of the same features. So it's got like the tracking of the app, the focus mode, the badge collecting, the games, and all of that. And so my app has been through a few iterations. This is an earlier iteration. So I've had like AI on the app using Core ML for iOS and TensorFlow for Android. As I've said, I've had notifications. I've had real-time Firebase database. So yeah, I've messed around with quite a few features across both Android and iOS before coming to its latest iteration. So yeah, I do have a little bit of experience messing around with both SwiftUI and Jetpack Compose. So I'm going to introduce myself at the end. Possibly you will have all stopped listening by then, but I will explain why at the very end. So, why should iOS developers care about Jetpack Compose? That's probably what you're all currently wondering. So, the mobile world has gone declarative and state-driven. So, a little bit about Jetpack Compose. V1 was launched in 2021. There was a V0 launched in 2020, but V1, the first stable version, 2021. It uses Kotlin. And it is declarative, state-driven Android development. SwiftUI, released in 2019 at DubDub. It uses Swift. And you can kind of see where this is going. It's declarative and it's state-driven. So again, why should iOS developers care about Jetpack Compose? Here are some of the obvious answers. Maybe you're in a multifunctional team, so maybe you're in a team that writes both native iOS and Android apps, and you have the horror of having to write both on a regular basis. Maybe you're like me, you've got a personal project where you wanted to ship natively across multiple devices, so you've learned a little bit of Jetpack Compose. Maybe you're just curious how these different languages, which are both state-driven, declarative, obviously functional as well, how they're different and how they're the same. Product alignment, which kind of comes into design consistency, the next one, so it's sort of how can you align both platforms? Maybe if you know a little bit, you can do that a bit better. Collaboration and hackathons. And maybe the odd PR review if you're in a really tiny team and the entire Android team, but bar one, go on holiday. But I have a slightly less obvious answer, which I will get to in a second. So we're all solving the same problems. What are those problems? I hear you yell. Unidirectional data flow. Don't talk to me about bindings, they're coming up in a bit. So unidirectional data flow is where the parent can talk to the child, but the child and the parent shouldn't really be talking, vice versa. And it is obviously a computing principle. State, the gnarly business that is state. What are the problems with state? Triggering too many redraws, we've all been there. State being tied to the view lifecycle and not persisted across both Android and iOS. State is really difficult to debug, so sometimes view redraws are being triggered and you have no idea why. And then there's obviously the fact that they're both declarative view compositions. So you can see a little bit of SwiftUI there and a little bit of Jetpack Compose as well, and they've got very similar styles. So we've got things like V stacks, H stacks, columns, rows, title, text, icon, image, image. So yeah, we've definitely got a lot of similarities in terms of that declarative programming. And then they've both got side effects. So SwiftUI deals with this with on appear, on disappear, on change. And then Jetpack Compose has launched effect, side effect, remember core routine, scope, etc. So yeah, I like how they just call it side effect. Call a spade a spade. So we're all solving the same problems, but we're solving them differently. So why should iOS developers care about Jetpack Compose? Here are a couple of the less obvious answers. So you can experiment on one platform, i.e. the easier one. So obviously, probably most of you are doing experimentation at this point, which is basically A/B testing, so users see different versions of an app. Experiments are meant to be sort of quick and dirty to see what's working and what's not working and get that data really quickly. If you've got both Android and iOS experience, you can go, I know this will be easier to build on this platform. And then you can run your experiment, and if you then ship it to live, you build it on the other platform. So if you want a holistic UX approach to navigation, then having a sort of person who knows how both Android and iOS works can input into that navigation approach and say, this would work well on SwiftUI, but this would be really hard to do on Jetpack Compose, and vice versa. Thus, if you want it to be the same across both platforms, you can kind of have a conversation and make it the same. And you can understand why your Android counterparts might be pushing back on certain elements or features, or why things might take longer for them or take a lot less time for them, if you've just got a little bit of an idea of what Jetpack Compose does. So, the bit you were waiting for, the comparison. And because this is so important, it gets 2 slides. Firstly, state. I'm sure you're all wondering what is the difference between how both Jetpack Compose and SwiftUI handle state. So in both Jetpack Compose and SwiftUI, state triggers view redraws. So you can see in this slightly blurry diagram, an event happens like a button press. State is updated, display state is then changed, triggering a view redraw. I said I'd come back to them. So SwiftUI has bindings. The concept of bindings is where the parent can give state to the child, and the child can update the parent's state. Bindings can only go one layer deep. There is a very ominous note in Apple Docs that says, if you bring your binding multiple layers, very strange things will happen. I can confirm this is true. Compose, on the other hand, does this thing called state hoisting. So if you've got this lazy column that has this concept of the lazy list state and you want it in the user input screen as well, you would have to hoist the state. So the state has been hoisted up, as you can see, to the conversation screen, can then be passed to that user input component. So state hoisting is where you declare the state at the highest possible point so that you can share it between the child views. To get around this, SwiftUI has the concept of the environment. This is where state is available anywhere from any point of your application. So a little summary of the differences between state. So state hoisting makes it easier to reuse components and pass state up the tree in Jetpack Compose, as we just saw. At state and at binding make state management more tightly knit in SwiftUI. So it's harder to scale, but it is easier, in my opinion, to build prototypes or hack projects really quickly, because you don't have to think about so many elements to do with state. The environment object does require careful planning because obviously it's shared amongst the entire app, so you can get some very strange behavior if you don't know what redraws are being triggered. But it is a really, really quick way to get state everywhere in your app that Jetpack Compose does not have. And on SwiftUI, state lives inside the views or external objects. So the whole view is recreated when state changes. Jetpack Compose is much more fine-grained, so it sort of redraws individual elements rather than redrawing the entire view. This means that Jetpack Compose can be more performant when you've got state issues, but also, like I said, SwiftUI can be a little bit quicker to knock up those projects. Navigation. So in Jetpack Compose, navigation is top-down, whereas in SwiftUI, navigation is bottom-up. What do I mean by this? I hear you ask. So Compose has all of its data up front. So you sort of have to have everything as you go into your application. It needs to know exactly where everything's going. It's more like the navigation stack that we've seen in SwiftUI now. So it sort of needs to know where everything can go at the entry point of the app. Whereas SwiftUI data lives inside the components. And components largely handle their own navigation. So if you've got a navigation link, that would go into the next bit of your view. And obviously that would handle its own navigation. So what does these differences mean when developing applications? So Jetpack Compose, as I said, has a centralized navigation graph. And it's got this concept of the back stack, so it's pushing and popping off the back stack. While SwiftUI has a decentralization, state-driven navigation through views. So each individual view knows where it's going next. It's got much more of a concept of place in that view. Navigation in Jetpack Compose is really complex, and navigating in the navigation graph is tricky. So you've got to think about it up front. It's like that navigation stack, as we've said. I personally find navigation in SwiftUI a lot easier to follow because you can just see exactly where your view is going on a button press. Whereas, the Jetpack Compose equivalent will just say, call the navigation stack. Architecture. I found architecture between the two one of the biggest differences, actually, when I tried to remake my app. So SwiftUI likes absolutely everything done on the view layer. I'm sure we all know that. Things like at environment and app storage, that's quite hard to say actually, at app storage are only available on the view layer. So it really pushes you towards that view layer. It really pushes you to declare everything in the view. Jetpack Compose is the exact opposite. So in Jetpack Compose, they have the concept of the view model baked in. So that's not that view model abstract class. I've not created that. That's a concept baked into Jetpack Compose. And they really insist that you use their view models. So it's much more testable. It's much more clean in terms of how you would architect an app. But it means for those hack projects, for those sort of personal projects, for getting things working, it's very much forcing you to use a certain architecture. So the architectural differences. So Jetpack Compose, as I said, is really, really opinionated, and it will force you to use the architecture, whereas SwiftUI is much more chill. It will let you do what you want with it. Jetpack Compose integrates really cleanly with clean architectures. And SwiftUI is very chill, which we like. So differences on the store. This is more for like the indie developers amongst you who might be thinking of putting your own app on the Play Store or have your own app on the App Store. So this is my App Store listing for Google Play. I had just uploaded a new version, so it looks like I have a great crash rate, but terrible install base. But yeah, that's how the store looks. And then hopefully we all recognize this. This is how the App Store looks, which I think is just a little bit nicer UI, much more pictures. We like pictures. So the differences at app launch, there are quite a few differences I found when getting my app onto the Play Store compared to the App Store. So firstly, Google need 20 users to have downloaded your app as testers before they'll put it on the store, whereas Apple does internal reviews. I use these tester groups that you can find on Reddit, so you can sort of sign up to use somebody else's app and they'll use your app. You have to have the app on your phone for a certain amount of days, so it can be quite a hard requirement to meet. Whereas the flip side of that is when I sent my app to Apple, the internal review went back and forth a few times. I think it took me 3 attempts to get it on the store. They rejected it twice. Yeah, so Google don't add you to the search straight away, which I didn't realize. So when I said to all my friends, download the app, they all went, how? It's really frustrating. But they only add you to the search after you've got a certain number of downloads. So the Play Store is a little bit more exclusive. Apple add you to the search straight away. You will look like a very suspicious character because you'll need 2 phones and 2 OSs if you want to launch on both stores. So this is something I've also noticed is in terms of updates. Obviously, both Android and iOS require updates. Android will threaten to take you off the store if you don't update immediately, so they're quite demanding. Apple, on the other hand, just say, we won't let you publish a release until you've done the next update. So that's sort of, I don't know if you'll remember, but we had to do some stuff for Apple around security or around legal things. And they just say, just do it in the next release. So it's much more chill. So a quick summary. So Jetpack Compose and SwiftUI look the same on the surface. They're both declarative, they're state-driven, and they're mobile technologies. In my opinion, they have 3 key differences. These are state management, as discussed, navigation, and architecture. Knowing the differences will help you build components that work beautifully on both. So if you know a little bit about these 3 differences, you'll be able to feed into your UX process and get something that works really good across all platforms when developing native apps. If you go wrong, you'll definitely be in some horrible state-driven redrawn nightmare regardless of the platform. They're very unforgiving. And I said at the beginning I was going to introduce myself at the end, so I'm sure you've all been waiting for this bit. So, my name is Hannah Downey. I was an iOS developer. That's sort of where I started. And obviously started off loving the iOS world with my own app on the App Store and things. I then moved to become a principal developer across both Android and iOS in a multifunctional team. So I was able to use my experience across both platforms to feed into the technical vision across Android and iOS. And now, plot twist, I'm actually a secret backend team lead hiding amongst you today, with a couple of apps on the Play Store and the App Store. Please don't boo me. So why did I save this until the end? Because I think that good coding practices span any language. So regardless of whether you're using Kotlin, Swift, Scala, Java, what other languages there are, I think good coding practices are what's more relevant than the language. I think that language technologies are temporary. So I have, in my short iOS journey, seen the deprecation of Objective-C and UIKit. Unfortunately, my company did start making something called Article UIKit just as SwiftUI was released. So that was a lot of work. I think, personally, iOS developers adapt really, really quickly from what I've seen in the industry. So I think we're used to having new stuff thrown at us, and I think we're really great at using new stuff. And I think we have an ability to adapt that I don't see in sort of the front end and back end of web technologies in the same way. Because I think, yeah, once a year we get a whole list of new things to implement, and we just go with it. And I think that good architecture design is agnostic of language. So if you're good at designing iOS apps, you'll be good at designing Android apps. And this is just my personal reflection, but yeah, being open to trying new things has helped my career and sort of helped me move around quite fluidly in the industry. So yeah, good luck, and maybe download my app. Thank you.